In this recording, we're going to look at how to solve problems, sort of a methodology for approaching solving problems that are posted on the Open Kattis platform. So right here, as an example, we're looking here at a problem on Kattis called the quadrant selection. And so when we go to these problems that are posted on Kattis, what they typically have is an explanation or some content that gives us some context on the problem, and then that is usually followed by some constraints on input and some constraints on the output. And then they provide a sample input and a sample output for the program that you're going to write to solve the problem. So Kattis provides the problem, and then when you submit the problem, you have a choice of many different languages. So in this example, I'm going to solve the problem with C#, and then we'll submit it so that you can see the entire workflow process. So first, let's go ahead and review this problem called quadrant selection. And so right here from the top, it just says a common problem in mathematics is to determine which quadrant a given point lies in, right? So there's 4 quadrants numbered 1 through 4 as shown in this diagram. So we've got quadrant 1 here where we need a positive and a positive x, y. And that gives us right here a point in quadrant 1 that can be graphed on the x and y axis. So here it says, for example, A, which is at coordinates 12, 5, lies in quadrant 1. So there we go. And so since both its x and y values are positive, and point B right here lies in quadrant 2 because the x value is negative and the y value is positive. So you get the idea. It's very basic, fundamental understanding. We have to write a program that is going to identify which quadrant, if the user were to type in the x and y values. So your job is to take a point and determine which quadrant it's in, and you can assume that neither of the two coordinates will be 0. So we want to make sure that that's the constraint here. Now we could program those constraints in our program, but what we're going to do is not program these constraints in. We're just going to run our test input within those constraints. But we're just making a simple example here on, as you get more and more into these Kattis problems, you may have to get more and more strict to abide by any test cases that go outside the boundary of the input constraints. The input integer for x is going to be right there. It's going to be greater than negative 1,000, greater than or equal to. It's going to be less than or equal to positive 1,000, and it cannot be 0. Whereas the second line contains the integer y, which is going to be greater than or equal to negative 1,000, or less than or equal to positive 1,000, and y cannot be equal to 0. So when we look down below the output of the quadrant number, right here, 1, 2, 3, or 4, for the point x and y. Here's the example here. So x here in this case would be input 10. Y would be input 6. If the user were to enter these two input values, you should expect to see quadrant 1, right? Because 10 is positive, x is positive. 6 is positive, so y is positive, so positive and positive gives us quadrant 1. And here's another example where 9, or x is 9, so that's positive, and y is negative 13. So that we would expect to be quadrant 4. So here we have positive x, negative y. That puts us in quadrant 4. Okay, so now that we have a fundamental understanding of our problem, some additional information that Kattis gives us here is some CPU time limit. So this problem must be able to execute by the central processing unit of less than 1 second, right? And it cannot use more than 1024 megabytes of memory. This problem is also rated with a difficulty of 1.3, okay? And if we wanted to, there are some sample data files that we could build with our program to absorb as input when we run our test cases, our use cases. So, but in this case, we're just going to run, for simplicity of this example, I'm just going to use these sample inputs for our problem. Okay, so what we can do a lot of times before we begin to write code is perhaps what we could do is whiteboard our problem a little bit. Helps us understand what we're going to do. So I've got a whiteboard here I'm going to create. And we know we have two variables that we're working with, right? And they're going to be an integer value. So what I'm going to do is, I know I'm going to have an int x and I'm going to have an int y. That's our x and y axis, right? So if we were to draw our x and y axis here, here's our y, right? And there's our x, okay? We know a couple of things. If we had two integer values, x and y, we know that if we had x greater here than 0 and y, right, was greater than 0, then with that value, that would put us right here in quadrant 1, right? So we also have quadrant 2, we have quadrant 3, and quadrant 4, right? So what we can do while we whiteboard is just think about the logic of solving this problem before we write any code. So let's continue the same sort of whiteboarding. So if x is in quadrant 2, x has to be, right, less than 0, y has to be greater than 0, right? So let's go to quadrant 3. What is quadrant 3? Well, in quadrant 3, x has to be less than 0, and y, right here, has to be less than 0. And finally, with quadrant 4, when we look at that, quadrant 4, x is going to be greater than 0, and y, right here, is going to be less than 0. So we look at this, and from this, we sort of work through visually the problem, and we understand, okay, we have two variables. We just then need to write some conditional logic that meets this requirement right here on our whiteboard. That helps us think through the problem. So what we're going to do is we're going to go from this stage of understanding the problem, its inputs and outputs, to whiteboarding, to actually writing code to the problem. So in this case, I'm going to use Visual Studio. And I'm going to write a console app right here in C#. And I'm going to go ahead and just create this problem. And we'll call this the quadrant selection problem. Okay, and I'm just going to put it right here in my repos. Okay. And we're going to go ahead and create that problem. Okay, so Visual Studio is going to create all the files necessary for me to begin to code out this solution. I'm using Visual Studio 2019 Community Edition. Okay, so when our project gets created in C#, we have right here, if we're just writing a simple console application, the reason why I chose a console application to solve this problem really is because when we're trying to solve these problems in Kattis, all we're trying to do here is just receive basic input into the problem. And you'll see when I go to submit it, we don't ask for any input from a user, right? So we don't write a program that asks the user the question like, what is your x-axis, or enter x. We don't do that. We just simply allow the program to receive input, and then we perform the calculation that's required to solve the problem, right, or execute the algorithm, and we have it essentially write that out to the console if we're in C#. And a similar thing would be no matter what language, whether we were using Python or any other language. So at a minimum, to run a console application in C#, we're required to use the system objects right there included in the .NET framework. That's really all we need right here for this problem. C# automatically creates my namespace, which is the same name of my project, project, quadrant selection, and I have a class that's going to run, and again, that's the same name as the .cs or the C# file. So right here, that's my class. That's why it's called program. I had no need to rename this for the submission of this. And I only have one method, my main method, that can receive arguments. Okay, so all we're going to do here is we know that from our whiteboard sketch that we have two variables right here that are integer values x and y. So I'm going to go ahead and define those in my program. And I'm going to say int x is equal to, and I'm going to parse the user input that I get from the console program. And the reason why I have to parse it to an integer, because any input received from a user is going to be interpreted as a string. So I'm going to read the line that the user types in. So console.readLine. And all I'm going to do is the first integer value or the string that the user types in, if they meet the requirements, that x axis, I'm going to parse that out as an integer. So then we're going to define another variable that we're going to call our y, which gets the user input for the y axis, and we're going to do the same thing. Okay, so there we go. We've got our two variables and we've acquired them and we've parsed them as integers. Now we can go ahead and write the logic to solve our problem. So I have an if condition. Remember when we sketched out our problem, we said if x is greater than 0 and y is greater than 0, then we put it right here in quadrant 1. So we're going to continue to write that logic into code. So I'm going to say if here x is greater than 0 and y is greater than 0, right? Then we can go ahead and what we could do is console.write, and the requirement was that it gives us 1 as our output. That's it, right? So then we just continue that same logical structure, testing for the value of x and y, and verifying that to find out which respective quadrant that we are in. Okay, so then I could just say else if, right? So for quadrant 2, x is less than 0 and y is greater than 0, right? We'll go ahead and console.write 2. End with that semicolon in C#. Let's keep going. Else if, let's go ahead and get quadrant 3. So in quadrant 3, if x is less than 0 and y is less than 0, right? That puts us in quadrant 3. There we go. End with our semicolon. I'm just going to go ahead and write out the same syntax. I could just say an else, to end it, but just for the sake of making sure that I'm writing out my logic here. And y is less than 0. And that gives us quadrant 4. And there we go. So we could verify that logic right here, right? So we go back, we take a look at our sketch, right? X is less than 0, y is greater than 0. We just kind of look this over, make sure everything is matching up. There's always a possibility with something like this, you make a little typo. Those kind of things happen. Okay, now that we've got our program written, we can go ahead and test our program with the sample input. So what I'm going to do is I'm going to run our program and it's going to launch the console. Okay, now that we have our console window up and running, we can go ahead and run our sample input. So I'm going to enter in the number 10. and hit return, and then I'm going to enter the number 6 and I'm going to execute that. So the program then calculates quadrant 1 based off the logic that we put in the C# code. Okay, so now that we've got that, we could do a couple of different things. We could copy this code and paste it inside of Open Kattis when we submit the problem, which I could do that easily. I could just copy this code, or I could actually navigate to the file itself. Okay, for the simplicity of this example, I'll just copy this code. We could navigate to the program.cs file if we wanted to. Okay, so what I'm going to do is I'm going to go right here to Open Kattis, and then you'll see this right here, this Submit button. So when we click on the Submit button, it'll open up a web page. And in that web page, we have really two options. We could open up an editor right here, and we could just paste our code that we wrote. That's one way. Okay, or we could actually navigate to the file itself. Okay, I just pasted the code just for simplicity. Okay, you don't have to do that. You could navigate to your file and it'll upload it. We changed the language. The default there was C++, but we programmed ours in C#. But notice that there's many other languages that are available in Kattis that you could choose if you do not prefer, right? So if you don't prefer C# in this case, Python 2, Python 3, those are common ones, C++, many different languages here. Okay, so we'll keep C#. So once we do that, we've got our code there, we go ahead and we submit it. And when we do that, what will happen is, depending on which language that you selected, Kattis will then go ahead and run a series of test cases. And it will compile the code right here. And you can see that it ran multiple test cases right here. And if we did a great job, it shows that after all of these test cases, green checkbox, that the solution was accepted. And then down below here, you will also see that your code right here, if you want to look back later on, you would see the code that you used to solve the problem. And here you can see in CPU, you met the requirement of less than 1 second, so it took 0.02 seconds for the language C#.